So let's look at 2024 AMC 10A problem 25. The figure below shows a dotted grid 8 cells wide and 3 cells tall, consisting of 1 by 1 squares. Carl places 1-inch toothpicks along some of these sides of these squares to create a closed loop that does not intersect itself. The numbers in these cells indicate the number of sides that these squares that are to be covered by toothpicks, and any number of toothpicks are allowed if no number is written. In how many ways can you place the toothpicks? So we can start analyzing this problem by looking at these sides. So basically we want to look at the most left and most right squares. Why? Because these squares here can only have one toothpick. So it's either up, down, left, or right. You can only choose one. Okay, so let's say if you chose to place this toothpick for this box here on the left, right? Then what options do you have? Well, you can either go up or go down, because you can't go right because you'll touch the side of the square again, which is not what you're supposed to do. So let's say you go up, right? And then obviously you have to move to the right. So now is the choice. So either you can go down and then go right, because that's the only direction left, which works, or you can go right and go down and then go down, which kind of seems to also work, right? Well, not really. If you go this way, then this square already has a toothpick right here, so you obviously automatically skip the square then, and you end up like this, right? Skipping all the every 2 squares, and then you do this. But which I guess you kind of make it to the other side of this toothpick grid, but it says that the toothpicks create a closed loop. So basically it has to be like a shape, and this is just like a line. It has to be like some rectangle or some square. So that doesn't work. So our only method here then is to go right. Is to go down. Wait, I'll use red. Okay, to go down. And then go to the right, which is vertically. And similarly, you can't just and then similarly the one thing you can do right now is just go back up. And then again go to the right, and then you can choose to go down or just move on. So let's say we chose here to continue and place this toothpick here. Then what does that mean for this square? Don't we just skip this top side? Well, remember that our other option here is to go down, right? We have to go down here, and then there's also another side to this closed loop of toothpicks. So here, this toothpick is already touching the square. So this toothpick in this column cannot be touching the square, so it has to be here, right? And then this toothpick doesn't touch the square, so this toothpick has to be here. So you go back up like this, and then similarly here. So we can complete this, right? Notice that for any toothpick that you cover here, the toothpick on the bottom would be here. For any toothpick that you don't cover at the top, the bottom toothpick will be here. So this is kind of like a push and pull, or this is kind of like a shape where you push in the sides. So we can complete this shape in some way we want. Okay, let's say we did this then. and this shape like makes sense, right? And then in the end what we do is, well, okay, wait. So for like the last toothpick at the right, again, you can only go down. You can only go down. And then go back up and meet at the side. Like, this toothpick can only be here in this case. So, yeah. That is like one of the examples, right? So how do we calculate the number of ways you can place a toothpick then? When you go when you go full on both sides, then in this case, for each of these squares, well, except for the first one and the last one, for each of these squares, you can choose if you want to place this toothpick at the top or the bottom side. And that's 2 options, right? And so this is like 2 options times 2 options times 2 times 2 times 2 times 2, right? That is 2 to the power 6, which is 64 choices. But obviously our answer choices are like double that 64 at least. So clearly we're missing out on cases. What are we missing out on then? Well, let me use blue. So there could be a case then where this side moves to the right. So like if we erase everything here, and we use like blue here for the side, then this could be like an option also, right? This could be also an option for our toothpick placement. So how many cases are there then? This is 2 times 2. So this is 2 times 2 times 2 times 2 times 2. 5 times, which is 32. And why did we know this works? Because basically for this square, the toothpick is placed on the right side. For this square, the toothpick is placed on the left side. And it's basically the same thing as what we saw just now, except there's like one less square of toothpick we need to consider. So it's like this rectangle shrinked and like one column got removed, right? Similarly then, we can do the same thing and shrink this side also. So how many ways are there to do this in total? Well, let's see. Since you have to cover all of these squares that say 1, the most the most you can do is shrink until here, right? So where you have this rectangle. And the other case that is left would be to keep this side. To keep this side and keep this rectangle, but to shrink this side and push this to the left. So there are 4 cases in total then. One is 64, one is 32, the other is also 32, and the last one, where it's the dark green rectangle, would be, so there are like 4 squares in the middle you need to consider for top or bottom side where the toothpick is. So that's like 16, right? So what is that then? 64 plus 32 plus 32, 128, so that's 144, which is in the answer choices. Like, at this point in time, when it's problem 25, and there's probably like 1 minute left on the test or something, you probably would be tempted to just choose B and like get this problem over with if you get to this point. But there are more cases to consider. So we've talked about the cases where this vertical edge with 3 toothpicks connected together exists, right? On both sides. So what if this isn't the case? Like, Okay, so the key to this would be then that this toothpick isn't placed here, or this toothpick isn't placed here. Instead, it's placed, say, on the top or on the bottom. So this entire rectangle is on one side of these squares. So an example could be this, right? Where this is obviously not considered in our previous cases, because our previous cases all considered where there were 3 toothpicks together like this going down. That is obviously one case, right? And there's also this case where, again, this is not considered, and like this rectangle doesn't fit with our previous casework. So are there any other cases here then? Okay, so let's see. We've considered when there's 3 sides together, when there's one side at the top, one side at the bottom. So like this and like this. And there aren't any other cases where like it matches the situation in the question where there's only one toothpick for the square. So this is 144 plus 2, which is 146 cases. So like that's probably where most people get things wrong, because once you figure out the like bit at the start with your logical reasoning or something like that, it's not that difficult. But the last bit where you have to actually add 2 and choose 146 instead of 144 is where people get it wrong.